So here's a schematic for a 555 timer and an N-channel MOSFET to work as a speed controller. Also, I didn't draw it in here, but it would work with two relays, and the relays would work to change the direction of the motor, and I'll explain that too. I just hadn't worked it into the actual breadboard here. I'm going to put this onto a little prototype PCB board and really make this a lot smaller and clean it up and 3D print a case for it and all that. But this is just to show it. I just put it together. So at my 1.5-year-old, I'm going to put him in a Power Wheels, but I don't like how I want to be able to control when he takes off how much power, overall power it has, how much top end power, and how much power it takes off the line. So that's what this circuit does. So say I gave it like a quarter of the throttle there. Now when I hit the foot pedal, and this is option, you can either have foot pedal or you can just have a potentiometer foot, like gas pedal. So that kicks it on. It only does it so far. I'll show you about holding it, but I can do. So if I turn it full blast and then turn it on, it'll be full blast. And say if I just bypass the switch, if I didn't want to use the switch. Does that make sense? So that works, and then the MOSFET I'm using here, it's 80 amps. It was just on the bench, I was using it for something else, but it's 80 amps, 320 peak, so really 80 amps continuous, that's a third of that. So you got to pick your MOSFET or double them up, parallel them. I'll be running an IRF 1404 or 1405 or something like that, 605 or something like that. So there'll be like 200 amps continuous, so it'll be more than good just to have one. So the relays, use two auto relays, and this has a common that's commonly connected to this 87A, the middle post here. So this is the 30s on the bottom, and then there's 80, 87, 87A, and these are your coils, 86, 85, and 86, or 86 and 85, whatever. I'll explain how this works. So, let's line this back up. So when you have your common, that means that these are commonly connected to these posts. So you have off your battery to the common, so it's connected to there, going to the battery, giving you your positive and negative, your clockwise. When you flick the switch, that means that the coils that are hooked up in parallel, they both get engaged and then disconnect from here to here and connect from here to here. And then switch your polarity, which is switching your direction now to counterclockwise. So that's very simple and easy to do. You can do that right at the motor. You can have this hooked up right at the motor area, or you can have it a part of your speed controller. I'm not sure. Like you could have maybe even some smaller relays right on your PCB board. Like these ones, I'm not sure how much they are. They're like 5 amps at 250 volts, or you get smaller ones. You can get them up to 5 volts, but I'm not sure how many amps they are, so you'd have to watch. But I know these ones, they're big. I have them up to 80 amps, these auto relays. So that should work really good. Yeah, like the 555 timer, this is 555 timer in A-stable mode, and a MOSFET, just pick a good MOSFET, and this circuit is pretty much tried and tested and proven. I didn't make it up, you know what I mean? Like this is a good circuit. And it's very simple. And like I said, if you use the relays, you have your forward and backwards, and that's all pretty easy. You can choose to have the on switch, or you can just have a potentiometer foot pedal throttle. Alright guys, hope you like that. Like, subscribe, share, And I'll be back with some more great videos. Cheers.